Good afternoon, guys. Coach Locke here. Today we're going to talk about graphing systems of equations. So, over on the right hand side, I've got two different equations. And when we're going to graph two onto one coordinate plane, we call that a system. And with the system of equations, you're going to get three different options. One, you're going to get a line on top of a line, meaning they have the exact same y-intercept, they have the exact same slope. And those things will cross. Well, they'll intersect at every single possible point, meaning that there are infinite answers to that. You will get ones that intersect at one point, meaning that they have one solution to that, meaning there's one x and one y that'll make both equations true. And the third option is you will get two lines that have the exact same slope and different y-intercepts, which means they will never cross. They're parallel lines. And if they never cross, then they have no solution. So once again, with the system, we're looking for where these things cross. So I'm going to start with my blue equation, and I'm going to graph it by starting at the y-intercept of +4. And I'm going to adjust by my slope of -3/1. So and that's -3/1. So I'm going to go down 3 and +1. -3, +1. I could continue that pattern out. I could go, up 3, down 1. But I like to get a couple points on there, then go to my other equation. This time I'm going to start at -2. And my slope here is going to be +3/+1. Now I could go down 3, down 1. But when I do that, I'm getting farther away from my blue line. Let me go ahead and draw my blue line out here, so you guys get a basic idea of where of where they may intersect. So notice if I have a green line going in this direction, they're going to intersect somewhere over in here. So that's why I don't go down 3, down 1. It's just kind of a waste of time to do that. So I'm going to go up 3/1 because that's my slope. At this point, I just stop and I go ahead and draw my other line, even though it won't hit the exact points going forward. I just stop there because I know these two lines intersect at that point. And that point is 1, 1. So the solution of this system of equations is going to be 1, 1. And if we want to double check that, we can. We can go into our blue line, and the y value is 1 times or equals -3 times 1 +4. And if we simplify the right side of this out, we see the 1 equals -3 times 1 is just -3. -3 plus 4 is 1. So that thing is a true statement. For my second one, the y value is still 1. Because remember, we're trying to find where the x and y are the same for both equations. 3 times the x value of 1 minus 2. And then simplify the right side out. 3 times 1 is 3. 3 minus 2 is 1. That is also a true statement. So both of these will intersect at the same point. Now, kind of what I was talking about originally, you just saw where we had lines that intersect. And they intersected at a point, which gave us the answer. The other option you may have, like I said, I'm going to try to draw a couple points here so you can see. Notice my slope is up 1/2. So the same thing, if I get another line that is up 1 over 2, these things will go on and on forever and never cross. So the blue and the green line would be parallel because they have the same slope of 1 over 2. Okay, and they also have different y-intercepts. Up 1 over 2, up 1 over 2. The blue line's got a y-intercept of 4. And the green line has a y-intercept of up 1 over 2, up 1 over, up 1 over 2, up 1 over 2, up 1 over of a half. So because they have different y-intercepts, it's not the same line. But if I had lines, say we've got a line here or point there, I'm going to use a negative 1/2 this time as my slope. So that line would be y equals negative 1/2 x, and then a positive 7. If I get another line with that exact same slope and that exact same y-intercept, then it would sit directly on top of that line, and they would intersect at every possible point. So if we get one like that, we say that it has infinite solutions. If we get one like the other one, like the blue and the green, we say that those have no solutions.